Hello and welcome to today's lesson on series and parallel circuits. Our learning outcomes are to describe the difference between series and parallel circuits. You've probably encountered series and parallel circuits already at Key Stage 3. A series circuit, like we have here on the left, is one complete loop, whereas a parallel circuit, like the one on the right, has branches where the current can split in two or more directions. I'd like you to now look at these 6 different circuits. Identify whether they are a series circuit or a parallel circuit. Now there's no need to write anything down, but pause the video now while you work it out, and once you're happy, press play on the video again. A is a fairly simple series circuit. B is a parallel circuit because it branches off. C is a series circuit. D is a parallel circuit. E is another parallel circuit. And finally F is another series circuit. Just a quick reminder about electric current and measuring current. Whenever we use an ammeter to measure current, we always have to have it in series. That is so that the electrons will be passing through both the ammeter and the component. So in this case, the same number of electrons passing through the bulb and the ammeter. In a series circuit, the current remains the same throughout. So in this example, where we have at the top right an ammeter reading 1 amp, the current will be the same throughout. So where it says A1, the current will be 1 amp, and A2 will also be 1 amp. In a parallel circuit, the electrons have the option to split up and go one way or another. In this case, an electron can either pass through the top bulb or the bottom bulb. You may find it easier to think of parallel circuits as having multiple loops, as they're shown here in this diagram. Now we have a question for you. If we have 4 amps coming out of the cell at the top of the circuit, how many amps will be flowing through A1, A2 and A3? Pause the video now while you work it out. The current of 4 amps would split up 2 amps and 2 amps over the 2 bulbs and then recombine to make 4 amps at the end. Here we have a similar situation, but this time it is 6 amps across 3 different bulbs. Pause the video again while you work it out. And this would give 2 amps across each bulb, recombining again to make 6 amps for the final ammeter. A slightly more taxing problem this time. What is the current that would read at A1, A2 and A3? Just bear in mind, it will be harder for current to flow through 2 bulbs in a row in series than it will be to flow through 1. Pause the video while you work it out. So 2 amps would go through the easier route, the one with less resistance at the top, and 1 amp would travel through the bulbs at the bottom, and then recombining again to make 3 amps. Don't worry if you did make a mistake on this, it is a tricky one. I'd now like you to copy and complete this paragraph to summarise what you've covered. Pause the video while you're doing it, and when you've finished, press play again and check your answer. And here is the answer. Please check your work and make sure you correct any mistakes that you may have made. We're now going to move on to looking at potential difference. Potential difference is the difference in the electrical potential between 2 points. So here we have 2 electrons either side of a bulb, and on one side it is connected to a potential of 1.5 volts, on the other side it is at 0 volts or earth. The potential difference is 1.5 volts. In order to measure potential difference, we need to use a voltmeter connected over the component or in parallel with the component. Now a question for you. What would the voltmeter at the bottom of this image read? Fairly easy one to start with. The voltmeter would read 1.5 volts, just like the voltmeter above it. A slightly trickier one now. What would the voltmeter on the right hand side of this diagram read? As all of the wire would be at the same electrical potential, there would be no potential difference across the wire, so it would be at 0 volts. One way of thinking of components in a circuit is as a series of obstacles for the electrons. Each electron has a certain amount of energy at the start of the circuit and has to give up some of that energy to overcome each obstacle. The potential difference across an obstacle relates to the amount of energy transferred by the electrons to the obstacle. In this example, the electrons would transfer energy equally across each of the 3 bulbs. In this example, we have 1.5 volts across the battery. What would the potential difference across each cell be? Remember, each cell will take some of the energy from the electrons. The potential difference across each bulb would be 0.75 volts, or half of the total voltage. The voltage across each bulb is 3 volts. What is the voltage across the 2 cells? The 2 cells together would produce 6 volts. What would the missing voltage be here? The answer would be 4.5 volts. What would the potential difference be measured as over the 2 bulbs in this circuit? Each bulb would measure a potential difference of 1.5 volts, just like the power supply. I'd like you now to copy and complete the following 2 sentences, filling in the gaps with either is equal to or splits up as appropriate. Pause the video now while you do that. And here is the correct answer. Please mark your work, and if you've made any mistakes, make sure you correct it, preferably in a different coloured pen. And to finish off with, we've got a couple of extension questions. These aren't mandatory, but if you have a go at them, you might surprise yourself. Pause the video now while you work through this first question. And here are the answers. Make sure you mark your work and correct any mistakes you may have made. And here's the final extension question. Once again, please have a go, but don't worry if you can't get all the way to the end. Pause the video now. And here is the answer. I hope you found this video useful and that it's given you a better understanding of series and parallel circuits. Thank you very much.